Graphing natural log, given f of x equals ln of x squared minus x. Part A, find the domain of the function. The domain of the function is a set of x input such that f of x makes sense. Whatever x is, f of x needs to produce a real number. But we know that the argument of log, in this case x squared minus x, whatever we put inside of log, it has to be strictly greater than 0, positive numbers only. To solve this inequality, we factor out x to get x times the quantity x minus 1 greater than 0. Recall that to solve the inequality, we first pretend that we solve the equation. If we solve this, we have x equals 0 and x equals 1. Then we have on the x number line, we have 0 and 1 as our breakpoint. We then check the sign of each of the interval. Pick any number in the first interval. In this case, -1 is in there, and plugged it in to see if this is greater than 0. -1 minus 1 is -2, and so we have -1 times -2, which is yes, positive. And so this is a good interval. Pick any number in the next intervals. This is 1/2, for example, but we can pick 1/3 or 5/9 or any number in this interval between 0 and 1. Usually we pick a convenient number. 1/2 minus 1 is -1/2, so positive 1/2 times -1/2 will be negative, which is not positive, and so no, we don't want this interval. Next, pick a number in this interval such that x equals 100, but 2 will work as well. Any number in this interval. 100 minus 1 is 99, and 100 times 99 is surely positive, so this is a good interval. And so on this number line, the intervals that will give us x squared minus x positive is -infinity to 0, and then 1 to infinity. We conclude that the domain of the function f is, using interval notation, -infinity to 0, parentheses, union with 1 to infinity. We cannot use 0 and 1 because if we plug in 0 and 1 into x squared minus x, this expression x squared minus x will be 0, and ln of 0 is not defined. And again, if we plug in any number between 0 and 1, then ln of x squared minus x will be undefined because x squared minus x is negative in this interval. Next, we graph the function f of x equals ln of x squared minus x. We see that because x equals 0 and x equals 1 are the breakpoints in this case, if we were to plug in a number that is almost 0 into this expression, then we'll get a very large negative number. Similarly, if we plug in a number that is almost 1, such that 1.000001 into this expression, then we have a very large negative numbers. We will end up with two vertical asymptotes, one at x equals 0 and one at x equals 1. Remember that there is nothing between 0 and 1 because the function is not defined between 0 and 1. And there is a vertical asymptote at x equals 1. We might also plug in another point to check. The more points we plot, the better. But eventually, the graph will look something that is similar to this. Again, we will have two vertical asymptotes. And ln of x does not really go all the way up. Eventually, it will increase, but it will increase gradually. This is the graph of y equals ln of x squared minus x. The domain is from negative infinity to 0 and 1 to infinity. The asymptote, vertical asymptote, will be x equals 0 and x equals 1. There is no local maximum and no local minimum because the graph will go down indefinitely, decrease it without bound at x equals 0 and x equals 1. And at x equals to infinity or negative infinity, the graph will increase without bound.